రైట్. మనకి ఏదైనా ముందు ఒక సర్క్యూట్ ఇచ్చారనుకోండి. సో సర్క్యూట్ యొక్క సపోజ్ సర్క్యూట్స్ లో ఇన్పుట్ ఏమో సమ్ వోల్టేజ్ సోర్స్ మనం కనెక్ట్ చేసాము అండ్ వీఆర్ గోయింగ్ టు క్యాలిక్యులేట్ ద current flowing through the some resistance at end of the circuit, let us assume. Then how we are going to calculate? So we are going to calculate that response based on mesh analysis or based on nodal analysis or by using the series parallel reduction. అంతే కదమ్మా, మీకు సర్క్యూట్ చదువుకుని ఉంటారు కదా, ఒక సర్క్యూట్ ఇచ్చి దానికి ఎంత 2 వోల్ట్ సోర్స్ 5 వోల్ట్ సోర్స్ వోల్ట్ సోర్స్ కనెక్ట్ చేసి అట్ ఎండ్ ఇఫ్ యూ వాంట్ టు క్యాలిక్యులేట్ ద కరెంట్ ఫ్లోయింగ్ త్రూ ది రెసిస్టెన్స్ ఆర్ వోల్టేజ్ అక్రాస్ ద రెసిస్టెన్స్ క్యాలిక్యులేట్ చేయాలి అనుకుంటే మీరు అప్పుడు ఏం చేసేవాళ్ళు, యూ ఆర్ యూజింగ్ ద ఇదర్ మెష్ అనాలిసిస్ ఆర్ యూజింగ్ ద నోడల్ అనాలిసిస్ ఆర్ యూ ఆర్ యూజింగ్ ద సిరీస్ ప్యారలల్ రిడక్షన్. సో ఇన్స్టెడ్ ఆఫ్ దట్ వన్, ఇఫ్ we are able to calculate the two-port network parameters of that circuit, and then you can easily calculate the response either voltage or current using that two-port network parameters. So that is the one of the advantages by using the two-port network parameter. అంటే మళ్ళీ మీరు ఈ సిరీస్ ప్యారలల్ రిడక్షన్ మెష్ అనాలిసిస్ నోడల్ అనాలిసిస్ మళ్ళీ చేయని అవసరం లేదన్నమాట. Once you are able to calculate the two-port network parameters, using those parameters you are going to calculate the voltage response or current response directly. Simple matrix multiplication. ఓకేనమ్మా. సో సింపుల్గా మీకు ఏం చెప్పాలనుకుంటున్నానంటే, మీకు ఏదైనా ఒక సర్క్యూట్లో ఫర్ గివెన్ ఇన్పుట్ ఎగ్జైటేషన్ దట్ మే బి ఏ వోల్టేజ్ ఆర్ కరెంట్, అండ్ ఇఫ్ యూ వాంట్ టు క్యాలిక్యులేట్ ద అవుట్పుట్ రెస్పాన్స్ దట్ మే బి ఏ వోల్టేజ్ ఆర్ కరెంట్. సో క్యాలిక్యులేట్ చేయాలి అనుకుంటే, సో యూ హ్యావ్ టు క్యాలిక్యులేట్ ద you are calculating the response by using the series parallel reduction or mesh analysis and nodal analysis still now. అలా కాకుండా ఆ సర్క్యూట్ కి ఫర్ ద సేమ్ సర్క్యూట్ if you are able to calculate the two-port network parameters, using those parameters you directly calculate the responses just simply multiplying the matrix multiplication. That's it. And these parameters are remains constant until if you not change the any element in the circuit. సర్క్యూట్ లో ఏదైతే పారామీటర్ సర్క్యూట్ పారామీటర్స్ తీసుకుంటున్నారో ఆ సర్క్యూట్ పారామీటర్స్ చేంజ్ చేయకపోతే ఆ టూ పోర్ట్ నెట్వర్క్ పారామీటర్స్ కాన్స్టెంట్. ఓన్లీ ఎగ్జైటేషన్ మీరు చేంజ్ చేస్తే కరెస్పాండింగ్ రెస్పాన్స్ ఈజీలీ. ఓకే. వన్ థింగ్ ఐ వాంట్ టు కంక్లూడ్ యూ, దట్ ఈస్ if the passive elements that may be a resistance or capacitance or inductance within the circuit are not changes, then the two-port network parameter values are remains constant whatever may be the excitation you are given to the circuit. Okay. So finally I want to conclude it work చెప్పినారంటే ఒక conclude చేసుకుంటున్నా. two-port network parameters అనేవి ఏదైనా ఎలక్ట్రిక్ సర్క్యూట్ యొక్క క్యారెక్టరిస్టిక్స్ ని డిఫైన్ చేస్తాయి. ఈ two-port network parameters యూజ్ చేసి you can calculate the response of the circuit based on the excitation for whatever may be excitation. ఏ excitation ఇవ్వండి corresponding response అనేది మీరు ఈజీగా క్యాలిక్యులేట్ చేయొచ్చు. సర్క్యూట్ వల్ల క్యాలిక్యులేట్ చేయాలి అంటే యు ఆర్ యూజింగ్ మెష్ అనాలిసిస్ సపోజ్ సర్క్యూట్ ఇన్పుట్ వోల్టేజ్ ఏమో సౌండ్ వస్తుంది ఎవరిది. సపోజ్ మీకు ఒక సర్క్యూట్ ఇచ్చి ఇన్పుట్ వోల్టేజ్ 10 volts ఇచ్చి కరెంట్ మెజర్ చేయాలనుకోండి, you are applying the mesh analysis and calculate the current response. Okay na? Malli again if the voltage value changes from 10 volts to 20 volts, then you have to apply the mesh analysis and you have to solve the equations and finally calculate the response. Again you have to do. Alla kaakunda if you know the two-port network parameters of that circuit, so whatever may be the excitation you are given, you are easily calculate the response simply by matrix multiplication. మనం అవన్నీ డిస్కస్ చేద్దాం క్లాస్ లో. సో ఫస్ట్ ఇప్పుడు వరకు two-port network అని చెప్తున్నాను. సో వాట్ మీన్ బై అసలు పోర్ట్ అంటే ఏంటి? పోర్ట్ అంటే ఏంటంటే ఇప్పుడు ఫస్ట్ స్లైడ్ లో ఉంది డెఫినేషన్ ఉంది, లేకపోతే మన సర్క్యూట్ లో ఏ టెర్మినల్స్ దగ్గర అయితే ఎగ్జైటేషన్ ఇస్తున్నామో లేదా ఫ్రమ్ విచ్ టెర్మినల్ వీఆర్ గోయింగ్ టు మెజర్ ద రెస్పాన్స్. సింపుల్ గా చెప్పాలనుకుంటే ఇన్ ఏ సర్క్యూట్ ద టెర్మినల్స్ టు విచ్ వీఆర్ గివింగ్ ద excitation are the terminals at which we are calculating the response. Those terminals are called as a port. అంటే మన సర్క్యూట్ లో ఏ టెర్మినల్స్ దగ్గర అయితే ఇన్పుట్ ఇస్తున్నామో, ఏ టెర్మినల్స్ కి అయితే పవర్ అనేది ఇంజెక్ట్ చేస్తున్నామో, those terminals are called as a port. Or ఏ టెర్మినల్ దగ్గర అయితే మనం రెస్పాన్స్ క్యాలిక్యులేట్ చేస్తున్నామో, ఆర్ ఫ్రమ్ విచ్ టెర్మినల్ we are drawing the power, terminal we are connecting the load. So those terminals are called as a port. ఓకేనమ్మా? సో ఏ టెర్మినల్ కి అయితే మనం ఎగ్జైటేషన్ ఇస్తున్నామో, the terminals to which we are giving the excitation or giving the voltage input, that is called as a input port. This one, input port. Here we are giving the excitation. And the terminals where we are connecting the load are the terminals from which we are taking the power, we are drawing the power. So that is called as the output port. Okay, so every circuit has the two ports. One is the input port, another is the output port. So every circuit we can represent as a two in terms of the two ports. One is the input port, another is the output port. That's why this is called as a two-port networks. Two-port networks. So one port is called as the input port, another port is called as the output port. So port and the terminals of the circuit where we are giving the input power, where we are injecting the power, that is called as a port, input port. Or the terminals of the circuit from which we are taking the power, we are drawing the power, we connected the load, that port is called as a output port. So every network containing the two ports. That's why this complete discussion is about the two port networks. Every network contains the two ports. One is the input port and the output port. Input port ante input power ni ekkadaithe inject chestunnamo dani input port antamu. ఏ టెర్మినల్స్ దగ్గర అయితే లోడ్ కనెక్ట్ చేసి పవర్ ని డ్రా చేస్తామో దాన్ని ఏమో అవుట్పుట్ పోర్ట్ అంటాము. దట్స్ వై ఎవ్రీ నెట్వర్క్ కంటైనింగ్ ద టూ పోర్ట్స్, సో దట్ ఇస్ కాల్డ్ యాజ్ ఏ టూ పోర్ట్ నెట్వర్క్. ఓకేనా? సో మీరు ఈ స్లైడ్ లో చూస్తే మీకు అంటే మీకు ఇప్పుడు చెప్పింది సేమ్ థింగ్ డెఫినేషన్ ఉంటుంది. ద టెర్మినల్ పేర్స్ రిప్రజెంట్ ద పాయింట్స్ వేర్ సిగ్నల్ ఆర్ ఎయిదర్ ఫెడ్ అంటే ఇంజెక్ట్ చేస్తున్నట్టు, ఆర్ ఎక్స్ట్రాక్టెడ్, దట్ మీన్స్ వీఆర్ డ్రాయింగ్ ద పవర్. They are referred as the ports of the system or ports of the network. Okay na? So ఏ పోర్ట్ ఏ టెర్మినల్స్ దగ్గర అయితే సిగ్నల్ ఇస్తున్నామో, ఏ టెర్మినల్ కి అయితే పవర్ ఇంజెక్ట్ చేస్తున్నామో, ఏ టెర్మినల్స్ దగ్గర అయితే ఎనర్జీ ఇంజెక్ట్ చేస్తున్నామో, ఆర్ ఏ టెర్మినల్స్ దగ్గర అయితే పవర్ డ్రా చేస్తున్నామో, ఏ టెర్మినల్స్ దగ్గర నుండి అయితే ఎనర్జీ ఎక్స్ట్రాక్ట్ చేస్తున్నామో, ఆర్ ఏ టెర్మినల్స్ దగ్గర నుండి అయితే సిగ్నల్స్ ఎక్స్ట్రాక్ట్ చేస్తున్నామో, those are called the ports. So every circuit containing the two ports, one is the input port and the output port. And input port ante power ni fed chestam, power ni inject chestam, and whereas the output port means we are drawing the power. So that's why this is complete called as the two port network parameters. Two port network antam, two port network antam, endukante every network containing the two ports, one is the input port and the output port. Okay, ee between the port a box nu chusarama, a rectangular box undi kada, ఈ రెక్టాంగులర్ బాక్స్ ని వీ హ్యావ్ టు రిప్రజెంట్ ఇన్ టర్మ్స్ ఆఫ్ ది టూ పోర్ట్ నెట్వర్క్ పారామీటర్స్. ఆ లోపల ఏముంటుందో మనకు తెలియదు, బట్ దానికి ఈక్వలెంట్ గా వీఆర్ గోయింగ్ టు క్యాలిక్యులేట్ ద పారామీటర్స్. నెట్వర్క్ లోపల ఏముంటుందో మనకు తెలియదు, బట్ ఆ నెట్వర్క్ పారామీటర్స్ అన్నిటినీ కన్సిడర్ చేసుకుంటూ వీఆర్ గోయింగ్ టు క్యాలిక్యులేట్ ద పారామీటర్స్. Those parameters are called as the two port network parameters, and those parameters will represent the characteristics of the network, and those parameters can be used to calculate the response for the given excitation for given input. So that is the port. So I think you understand what I mean by port, and I think you understand why we called as the two port networks. I think you understand what is the need of the two port network parameters. Okay, so this is the basic information that what required for the two port network course. Okay, now we move to the next slide. Yeah. So what are the assumptions we are considered? What are the assumptions we are considered to solve any problem by using the two port network parameters? Or what are the assumptions we are considered to calculate the two port network parameters of the any electric network? So those are the assumptions are presented in this slide. First thing is, so I said that we are applying onto the electrical circuits. So So those electrical circuits comprise of the different type of circuit elements like resistance, inductance, and capacitance. But we are assuming that there is no energy stored within the storage elements like inductor and capacitor. మనం ఇంతకుముందు కూడా డిస్కస్ చేసాము ఈ చాప్టర్లో ట్రాన్సియెంట్ అనాలిసిస్ డిస్కస్ చేసాం. Assume initial current flowing through the inductor equal to 0, or assuming initial voltage across the capacitor equal to 0. Okay, right? So like that, but if we are going to calculate the two-port network parameters of the any electric circuit, you have to assume there is no energy stored in the storage elements like inductor and capacitor. That means we are going to assume that current flowing through the inductor equal to 0 and voltage across the capacitor equal to 0 initially. So that's the first assumption. No energy stored within the circuit. And within the circuit means ఇక్కడ మీకు ఈ బాక్స్ ఉంది కదా, ఈ రెక్టాంగులర్ బాక్స్ ఉంది కదా, మీకు చెప్పాను కదా, ఈ రెక్టాంగులర్ బాక్స్ is nothing but it is represent the circuit which consists of the different type of passive elements, resistance, inductance, and capacitance. Okay, but what the assumption is, we are assuming that there is no energy stored within the inductor and capacitor. That is the first thing, first point. This one. And no independent sources within the circuit. No independent sources. There may be a dependent sources, but no independent sources within the circuit, which is represented by a simple rectangular box. Which is represented by a simple rectangular box. So this containing the only passive elements like resistance, inductance, and capacitance. No independent sources. That may be a voltage source or that may be a current source. That may be a voltage source or that may be a current. So there is no independent source. Passive elements and only passive elements like inductor and capacitor. So that is the second assumption. The current into the port must equal to current out of the port. See, that means, so it is the circuit, rectangular box representing the circuit, and this is the input port, this is the output port. So what is the current entering into the port must be equal to current leaving from the port. And what is the current entering into the second port, that must be equal to current leaving from the second port. That means I1 equal to I1 dash and I2 equal to I2 dash. So what is the value of the current entering into the port, that must be equal to current leaving from that port. What is the value of the current entering into the port, that must be equal to current leaving from that port. Okay, that is the third assumption. And fourth one is, all external connections must be made to the either input port or to the output port, not within the circuit. Meek circuit lo majjalo don't connect the any connections. You have to give the external connections either to the input port or to the output port. No external connections are permitted within the circuit. So external connections are permitted only either at the input port or at the output port. No external connections are permitted within the circuit, within the network. So these are the assumptions while doing with the two-port network parameters. So this is some practical example where we can use the two-port network parameters. So see, you can find the amplifier here. You can find the amplifier here. So for this amplifier, we have to represent it with the two-port network parameters. There is a different type of two-port network parameters. We represent with any two-port network parameters. From the two-port network parameters, we are going to estimate what will be the output for the given input. What will be the output for the given input? Let's assume, suppose if I am applying the 10 voltage across the input here. By using the two-port network parameters, I am going to calculate the value of the voltage across the output terminals. Let's assume it is the 5 volts. So this information will be helpful for you to connect the how much rating of the speaker we have to connect at the output port of the amplifier. Example, I'm telling, let's assume 20 volts are connected to the input port. And by using the two-port network parameters, I am going to calculate the output voltage equal to 5 volts. Now I can decide speaker, how much rating of the speaker I can connect across the output terminals. Because the maximum voltage will be available will be 5 volts. 5 volts, right? So we can't keep the 2 volts or 3 volt speaker at the output terminal because it's producing the 5 volts. So that type of information will be helpful for you to utilize which type of speaker we can connect at the end of the output of the amplifier, output terminals of the amplifier. Even though we don't know anything, what will be the element, what are the elements available within the amplifier. Only thing available for us is only 2-port network parameters of the corresponding amplifier, and based on those parameters we are going to calculate the response or voltage response based on the input. And after getting that voltage response, we are going to decide how much rating of the speaker we can use, right? So this is the one of the application where we can use the 2-port network parameters. Now, in 2-port network parameters, we are going to use the 4 variables. Those variables are the voltage variables and the current variables at each port. We have the 2 ports. Each port has one voltage and another current. Similarly, second port also voltage and current. So input output anukunnamma konta voltage iste some corresponding current inject avutundi kada. So every port contains the voltage value corresponding current value. Every port contains the and output ports also. See here V1 voltage at the first port, I1 current at the first port, V2 voltage at the output port or second port, I2 current at the current at the output port. So 4 variables are available in any 2-port network. For one port, 2 variables. One is the voltage, another is the current. We have the 2 ports, so total 4 variables. One is so V1, I1, which are corresponding to the voltage and current at the first port. V2 and I2, which are corresponding to the voltage and current at the second port or output port. So we have total 4 variables, voltage and current variables in 2-port network parameters. 2-port network parameters. Right. See, V1 is the voltage at the port 1, V2 is the voltage at the port 2, I1 is the current at port 1, and I2 is the current at port 2. Right? Now, so out of 4 variables, we are going to choose 2 are the independent variables and 2 are the dependent variables. Please concentrate. We have the 4 variables, V1, V2, I1 and I2. Out of 4 variables, we are going to choose 2 variables are the independent variables, 2 variables are the dependent variables. That means the 2 dependent variables depending upon the 2 independent variables. Right? So I will tell you what it means by. So this thing you have to remember what are the variables for any 2-port network parameter. Right? Now we are moving to the Z parameters, the first 2-port network parameter. Today we are going to discuss. We have only 10 more minutes time. So if we are not able to finish, we will continue tomorrow at the same time, 4:50 to 5:30 every day. I will share the again. I will share the link and everything. So every day we have a class from 4:50 to 5. First, Z parameters are also called as the open circuit parameters, or it is also called as a impedance parameters. Right? These 2 equations, equation 1 and equation 2, are used to calculate the Z parameters. Z parameters will provide the relation between voltage at the 2 ports in terms of the current at the 2 ports. That means which provide the relation between V1 and V2 in terms of I1 and I2. It's a very simple. So just concentrate. Yeah. Okay. So Z parameters which are going to provide the relation between voltage at the 2 ports like V1 and V2 in terms of current at the 2 ports I1 and I2. That means V1 in terms of the I1 and I2, V2 in terms of the I1 and I2. So that's equal to V1 equal to Z11 I1 plus Z12 I2, and V2 equal to Z21 I1 plus Z22 I2. You have to remember these two equations, right? Here, V1, V2, I1 and I2 are called as the variables, as we discussed. Z11, Z12, Z21, Z22 are called as the Z parameters, or open circuit parameters, or impedance parameters. For any circuit, we need to calculate Z11, Z12, Z21, Z22, like Z parameters. How we calculate Z parameters, we are going to discuss now. Right? See, meanwhile, if for any of you, if it is possible to take the screenshot, please take the screenshot and share with me, because I am unable to do now, if possible. Right. I think if CR is available, please help in that case. Just take the screenshot and share with me, if possible. Otherwise, it's not an issue. Try to concentrate what I'm saying. That's it. Right. So V1 equal to Z11 I1 plus Z12 I2, V2 equal to Z21 I1 plus Z22 I2, where Z11, Z12, Z21, Z22, these are called as the, where I1 and I2 are called as the independent variables. I1 and I2 are called as the independent variables, where V1 and V2 are called as the dependent variables. Why it is called as the dependent variables? Because V1 and V2 are depending upon the I1 and I2. Right? Why we call V1 and V2 are the dependent variables? Because V1 and V2 are depending upon the independent variables I1 and I2. See, V1 equal to Z1 into I1 plus Z12 into I2. That means V1 is depending upon I1 and I2 values. And V2 equal to Z21 I1 plus Z22 I2. So the V2 is depending upon the I1 and I2. Right? So that's why V1 and V2 are called as the dependent variables. I1 and I2 are called as the independent variables. Z11, Z12, Z21, Z22 are called as the two-port network parameters. Disconnect. Okay, Nama? So right, good. Now, how we calculate the Z parameter? How we calculate the Z11, Z12, Z21, Z22? See, observe here first equation. Just see the first equation. How we calculate the Z11? See, if we make I1 equal to 0, sorry, if we make I2 equal to 0, put I2 equal to 0. That means if you put I2 equal to 0, this one, if you put I2 equal to 0, then what will be the first equation become? Then first equation become equal to Z11 into I1. Now what is the value of Z11? Z11 equal to V1 by I1. See, you can find here. Z11 can be calculated by making I2 equal to 0 and taking the ratio between V1 and I1. So Z11 equal to V1 by I1 at I2 equal to 0. At I2 equal to 0 and entama? At I2 equal to 0, then this whole term will become 0. This whole term will become 0. Then what is remaining in the first equation? V1 equal to Z11 into I1. So Z11 equal to Z11 equal to V1 by I1. So that is available here in the second slide. Z11 equal to V1 by I1 at I2 equal to 0. I2 equal to 0 and entama? And the current in the second port equal to 0. Current in the output port equal to 0. So current in the output port equal to 0 means that port will be open. If the port is open, no current will be flowing. If the port is open, no current will be flowing. Right? That means if you want to calculate the Z11, then just simply make output port open and calculate the ratio between V1 and I1. That value will give the Z11 value. We will solve the problem, then you can easily understand. Similarly, if I want to calculate the Z21, if you want to calculate the Z21, okay, then if you want to calculate the Z21, then how we calculate Z21? Just simply make I2 equal to 0. Simply make I2 equal to 0. Simply make I2 equal to 0. Right? If I2 equal to 0, so I2 0 చేయాలంటే ఏం చేయాలమ్మా? Just we have to open the second port. Output port, second port ఓపెన్ చేసామనుకోండి. సో పోర్ట్ అనేది ఓపెన్ అయిందంటే టెర్మినల్స్ ఓపెన్ లో ఉన్నాయంటే no current will be flowing through the terminals. That means I2 equal to 0. So when I2 equal to 0, then this equation will become V2 equal to Z21 into I1 and Z21 equal to V2 by I1. Z21 equal to V2 by I1. So that is available here. See, Z21 equal to V2 by I1 at I2 equal to 0. V2 by I1 at I2 equal to 0. Right? Similarly, suppose if I want to calculate the Z12. If I want to calculate Z12. So what you have to do now? Everyone, okal respond everyone. I think someone, anyone, can you respond? If I want to calculate the Z12, ఏం చేయాలి అప్పుడు?
I1 is equal to 0, sir.
Good. Right. So if you want to calculate Z12, make I1 equal to 0. Make I1 equal to 0. That means you have to open the first port. You have to open the input port. Make I1 equal to 0. That means open the input port. Open the input port. Then I1 equal to 0 kadamma. When I1 equal to 0, then V1 equal to Z12 into I2 and Z12 equal to V1 by I2. Z12 equal to V1 by I2 at I1 equal to 0. Right? Good. Similarly, if I want to calculate Z21, if I want to calculate the Z21, so if you want to calculate the Z21, then
I2 is
sorry. If you want to calculate the Z22, then we have to I1 equal to
I1 0.
I1 is
how we make I1 0? Just open the input port. Just open the input port. So when the first port input port is open, then I1 equal to 0, then V2 equal to Z22 into I2 and Z22 equal to V2 by I2. See here. Z22 equal to V2 by I2, but I1 equal to 0. So this is the way, these are the equations 3, 4, 5, 6 can be helpful for you to calculate the two parameters of any electric circuit. Right? To solve any electric circuit. So now we are going to solve, we are going to solve one small problem if time permits. Otherwise, we will continue in the next class. 1 minute. New share, whiteboard. Yeah. Right. See, friends. Now I want to choose one small circuit. I want to help you how we calculate the Z parameters of the small circuit. I will help. Now see, let's assume I am considering a small circuit. Yeah. Just a minute. Yes. Maybe. So let us assume it's a small T circuit, T network I'm considered. It contains the only resistive elements. So let us assume this is the 2 ohm resistance, and this is also 2 ohm resistance, and this is also 2 ohm resistance. Let us assume all are the 2 ohm resistance. So this is the first port, 1 dash. This is the second port, 2 and 2 dash. Right? Good. And here the input voltage is V1 and input current is I1, and output voltage port voltage at the output port equal to V2 and voltage current at the output port equal to I2. So this is the circuit I have. Now cheppandi, first I want to calculate the Z11. I want to calculate Z11. So how we calculate Z11? Anyone able to recollect? So how we are able to calculate the Z11?
Z11 is equal to
I2 0.
V1 by I1.
Good.
Z11 is equal to
I2 0, V1 by I1.
I1.
Right. Good. So I2 0 means the second port is open. Right? Second port is open. So no current is flowing to this 2 ohm resistance. No current is flowing to this 2 ohm resistance, right? Because second port is open, no current is flowing to this 2 ohm resistance. Right? Now, so now if no current is flowing through the resistance, then can I write V1 equal to can I write V1 equal to 2 into
group lo
I1 plus చెప్పండి ఒకసారి రైట్ 2 into I1 plus 2 into I1, right? Because there is no current is flowing through this 2 ohm resistance, right? If the no current is flowing through this 2 ohm resistance, so no current is flowing through this 2 ohm resistance. Okay, then if no current is flowing through the 2 ohm resistance, then what the input current I1 is flowing through this 2 ohm resistance and flowing through this 2 ohm resistance is coming back. That means, so V1 equal to 2 into I1, that is the voltage drop across this one, and 2 into I1 voltage drop across this one. So V1 equal to 2 into I1 plus 2 into I1. So V1 equal to 4 into I1. So what is the value of Z11 now?
4.
Right. Z11 equal to 4. Good. Z11 equal to 4. Similarly, now how we calculate the Z21? Sorry. Now how we calculate the Z12?
I2 0.
Sorry, Z12. I want the value of Z12.
I1 is open.
I1 is equals to 0.
No. Z12, amma. Z1. Right. I1 equal to 0.
V1 by I2.
Right.
I2.
V1 by I2 at I1 equal to 0, right? So
Yes, sir.
I1 equal to 0 means input, there is no current at the input port. Okay, na? No current at the input port. No current at the input port. And I want to calculate V1 by I2. I want to calculate V1 by I2, right? Now tell me, in the given circuit, what is the value of V1? Everyone chapter V1 expression. V1 expression in terms of I2. Anyone can tell what is the expression for V1 in terms of I2? Because I1 equal to 0.
2 into I2.
Tali?
2
Right,
into I2.
I2.
Right. V1 equal to 2 into
I2.
to I2. So now what is the value of Z12?
V1 by I2.
2.
Right. Z12 equal to 2. Z12 equal to 2. Right. That's it. Now So we are calculated the Z11 and also calculated the Z12. Now I want the Z21. I want the Z21. How we calculate the Z21?
I2
I2 equal to 0.
I2 0. So this is open. Okay, na?
V2 by I1.
V2 by I1. Right? So now tell me what is the value of Z21? Anyone can tell? Z21.
V2 equals
Z21.
2 into I1.
Sorry. I am asking another way. So Z21 equal to V2 by. Sorry, I am asking.
I1.
I'm asking actually Z12. Z12 equal to V1 by I2 at I1.
I2.
So ఏమొస్తుందని చెప్పగలరు ఎవరైనా? Z12 V1 by I2.
2, sir.
So,
0.
no.
2 ohms, sir.
I want Z12. So Z12 equal to V1 by I2 at I1 equal to 0. So I1 equal to 0 means it will be open. Now I want the V1 by I2 value. So V1 by I2. First calculate the V1 value. V1 equal to voltage across the 2 ohm resistance. As I1 equal to 0, the total I2 current is flowing through this 2 ohm resistance only like this. So when this I2 is flowing like this, so voltage drop across the 2 ohm resistance equal to 2 into I2, that's equal to V1. So V1 equal to 2 into I2 and V1 by I2 equal to 2 at I1 equal to 0. That's why it's called as the Z12. Similarly, if you want to calculate the Z21, if you want to calculate the Z21, so if you want to calculate the Z21 equal to V2 by I1, V2 by I1 at I2 equal to 0, right? Z21 equal to V2 by I1 at I2 equal to 0. Okay, so now what do I have to do? Now tell me, when I2 equal to 0, the current flowing I1 through this 2 ohm resistance and this 2 ohm resistance and even fed back to the, and as I2 equal to 0, output port is open. Now, current is flowing this 2 ohm resistance. Now what is the value of V2? V2 equal to current flowing this 2 ohm resistance I1. So V2 equal to 2 into I1. 2 into I1. So V2 equal to 2 into I1 and V2 by I1 equal to 2 ohms. So what mean by V2 by I1 at I2 equal to 0? V2 by I1 at I2 equal to 0. That's called Z21. So Z21 equal to 2 ohm. Yes, 2 ohm. Right. Similarly, last thing I want to calculate Z22. How we calculate Z22?
Z22 is V2 by I2.
V2 by I2 at
I1 is equal to 0.
so V2 by I2 at I1 equal to 0. I1 equal to 0 and this first port is open. First port is open. Now I want to calculate the V2 by I2, right? Now current I2 is flowing to this 2 ohm resistance and this 2 ohm resistance and coming back to the second port. No current is flowing to here because it is open. Now can I write V2 equal to 2 into I2 and 2 into I2? Right?
Yes, sir.
V2 equal 2 into I2 plus 2 into I2. Just simple KVL. Kirchhoff's voltage law. So V2 equal 2 into I2 plus 2 into I2. 4 into I2.
4 ohms.
Yeah, V2 by I2 equal to 4 ohm. That's called Z2. Right? So this is how we calculate the two-port network parameter. Right? Anyhow, 1 minute. So now, see. Right. So this is now. Please try to solve this problem. So this is the circuit I am given. So try to calculate Z11, Z21, Z12, Z12, Sorry, the last one is the Z22, Amma. This is the Z22. By mistake, there is a printing mistake. Z22. This is the answer summary. These four are the answers, and this is the circuit. So try to calculate the Z parameters of this circuit and verify whether the values are matching with this one or not. Okay, Nama? Same procedure. So suppose if you want to calculate Z11 calculate cheyalankondi, how we calculate Z11?
I2 equal to 0.
Right. Good. So
I2 equal to 0.
I2 equal to 0. Now calculate the V1 by I1. అంతే కదమ్మా. సో ఇప్పుడు మనం క్వశ్చన్ చేయాల్సింది ఏంటంటే you try to calculate the I1 in terms of the V1, later take the ratio between V1 and I1. ఓకే చెప్పండి అమ్మా. సపోజ్ I2 ఈక్వల్ టు 0 అయ్యింది అనుకుందాం. అప్పుడు ఈ 5 ఓం రెసిస్టెన్స్ ఈ 15 ఓం రెసిస్టెన్స్ ఎట్లా ఉంటాయి? If the I2 equal to 0, then what is the 5 ohm resistance are in parallel or series? These are the series connection, right?
Series formation.
5 and 15 are in series connection. So what the total resistance here?
20
20.
20 ohms.
Yeah. This 20 is parallel with 20, right?
Series.
See, this 5 ohm and this 15 ohm are in series, and this complete branch is in parallel with this 20 ohms, right? Ante kadamma?
Yes, sir.
Right. Now what is the
Yes,
total
sir.
resistance?
10 ohms.
Right. Ante kadamma? This is 20, this one is 20, and this complete series 15 plus 5, that is the 20 again, and this 20 and this 20 are in parallel. అప్పుడు ఏమొస్తుంది R1 R2 by R2 plus R2 and 20 into 20 plus 20. అప్పుడు ఎంత వస్తుందమ్మా?
10 ohms.
10 ohms. Good. So these are 10 ohms. Now tell me what is the value of I1? I1 ఏమవుతుందమ్మా? I1 equal to
V1 by 10.
right. I1 equal to V1 by 10. Now మనకి యాక్చువల్ Z11 కావాలంటే ఎట్లా వస్తుంది?
I2 equal to 0.
Z11 equal to
V1 by I1.
Z11 equal to V1 by I1. ముందు చెప్పారు I1 equal to V1 by 10 అని కదమ్మా. You said that I1 equal to V1 by 10 కదా.
Z11 is equal to 10.
Right. Z11
I1 is equal to V1.
right. Because I1 equal to V1 by 10 and Z11 equal to V1 by I1. So definitely Z11 equal to 10 ohm. So same procedure try to apply. Okay, na? And try to calculate Z11, Z21, Z12 and Z22. This is the Z22. And verify with these results. And note it down on your notebook. మీ దగ్గర ఏదైనా రెఫరెన్స్ ఉంటే నోట్బుక్ లో నోట్ చేసుకోండి, లేకపోతే మీ దగ్గర మొబైల్ ఉంటే ఈ ఆన్సర్స్ ఏమో ఫోటో తీసుకోండి, ట్రై చేయండి. ఓకేనమ్మా. సో అది క్లాస్ రూమ్ ఉంటే ఇంకా ఎఫెక్టివ్గా ఉంటుంది, బట్ మనకున్న రిసోర్సెస్ని మనం యూజ్ చేసుకోవాలి. సో ఐ హోప్ కొంతవరకు అర్థమైంది అనుకుంటున్నా. ఇది ప్రాబ్లమ్ సాల్వ్ చేసి రేపు మనం అటెండ్ అయ్యేటప్పటికి మనం దీని మీద డిస్కస్ చేద్దాం. సో వన్స్ everyone are able to solve this problem, then we move to the y parameters tomorrow. Otherwise we complete this problem, later we move to the y parameters. Okay na ma?
Okay, sir.
Problem లేదు. సో ట్రై టు సపోజ్ మళ్ళీ డిస్కస్ చేద్దాం. ఇప్పుడు మనకు ఇది Z22 కదమ్మా. సో Z22 ఎలా క్యాలిక్యులేట్ చేస్తాం? హౌ వి క్యాలిక్యులేట్ Z22?
I1 equals to 0.
Z22
V2 by
I2 by I2.
V2 by I2.
V2 by
I2.
V2 by I2 at
I1 is equals to 0.
right. So I1 equal to 0 means this will be open. First port will be open, right?
Yes.
Must be open. This is open. Okay. Now I want to calculate V2 by I2 kadamma. So ఇప్పుడు ఫస్ట్ సో ఇంప్లెన్స్ ఏమొస్తుంది? ఆ రెసిస్టెన్స్ ఏమవుతుంది? ఈక్వల్ రెసిస్టెన్స్
20 and 5 are series.
20 and 5 are
Series.
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 So since these are in series, so 20 plus 5, 25, and that 25 is in
Parallel.
parallel. Ante kadamma. So this 25 is in parallel with the 15, right?
Yes.
Right. So now what is the total equivalent resistance?
9.375.
Right? 25 into 15 divided by 25 plus 15. That is the 9.375.
375.
Right na? Right. Now what is the value of I2 now? Tell me. I2 equal to emothundi? Current equal to voltage by resistance kada. Total resistance.
I2 is equal to V.
I2 equal to V2 by 9.375.
9.375.
So I want V2 by
9.375.
kadamma?
V2
So what is the
by
value?
I2 is equal to 5.
What is the value of Z2?
9.375 ohms.
That's it. 9.375.
375.
Right, perfect. Similarly, so these two are easy. Now, how we calculate Z21? Z21 ఎలా calculate చేస్తామా? How we calculate?
V2 by I1.
I want to calculate this one, Z21.
V2 by I1.
At I2 equal to 0 kadamma?
Yes, sir.
V2 by V2 అంటే ఇది. V2 by
I1.
at I2 equal to
At I2 is equal to 0.
second port is open. Right? Second port is open kadamma?
Yes, sir.
So first calculate V2 in terms of I1. How we calculate V2 in terms of I1? ఎవరైనా చెప్పగలరా? సింపుల్ అక్కడ ఉంది.
Z21.
ఇప్పుడు V2 అంటే ఏంటి? V2 నథింగ్ బట్ వోల్ట్ రెక్టర్ ద 15 ఓం రెసిస్టెన్స్ కదా. V2 is nothing but వోల్ట్ రెక్టర్ ద 15 ఓం రెసిస్టెన్స్, రైట్? అంతే కదమ్మా? కరెక్ట్ కదా?
Yes, sir.
Right. Now, first you have to calculate voltage across the 15 ohm resistance, that's nothing but V2. So voltage across 15 ohm resistance calculate cheyalante, you have to calculate current flowing through 15 ohm resistance. You have to calculate current flowing through 15 ohm resistance. So anyone can tell what is the value of the current flowing through 15 ohm resistance? I1 కాదు కదా, ఎందుకంటే I1 అనేది ఇది current flowing in the first port and the same current is splitted between 20 ohm resistance and through 5 and 15 ohm resistance kada.
Yes, sir.
So ఇప్పుడు ఏమొస్తుంది చెప్పగలరా? అంటే I1 అనేది I1 కరెంట్ ఇది, so it is splitted, that current will be splitted like this and the same current is splitted like this kadamma. But I want to calculate the current flowing through 15 ohm resistance. So anyone can tell what is the value of the current flowing through 15 ohm resistance? It's easy. Actually, current division rule use cheyali. You have to use the current division rule.
V2 by 15.
Let us assume I1 is the input current, right? And I want to calculate the current flowing through 15 current. Now, current flowing through 15 ohm resistance, this one. That's equal to this is the total current, and this 20 ohm and this 5 and 10 ohm 15 ohm resistance are in parallel. Current division గుర్తుందా? మీరు కరెక్ట్గా అబ్జర్వ్ చేస్తామా, ఈ 20 ohm రెసిస్టెన్స్ 5 and 50 సిరీస్ లో ఉన్నాయి కదా, ఈ నెట్ రెసిస్టెన్స్ ప్యారల్ లో ఉంటాయి. దిస్ 20 and 5 plus 15 20, దీస్ ఆర్ ఇన్ ప్యారలల్ కదా.
Yes, sir.
సో ప్యారల్ అయినప్పుడు టోటల్ ఇన్పుట్ కరెంట్ I1 అయితే ఎంత ఫ్లో అవుతుంది, ఎవరైనా చెప్పగలరా?
I1 by 20 parallel to 15 plus 5.
I1, this is the total current and the current is splitted 20 ohm resistance and this 20 ohm resistance 15 plus 5. Now I am asking what is the value of current flowing to this 20 ohm resistance 15 plus 5. నేను ఏమంటానంటే the value flowing to this 5 and 15 ohm resistance series branch is I1 by 2 అంట. ఎందుకంటే టోటల్ కరెంట్ I1 కదా, ఈ బ్రాంచ్ ఏమో 20 ohm, ఈ బ్రాంచ్ కూడా సేమ్ 20 ohm ఉంది. సో ఈక్వల్ రెసిస్టెన్స్ కదా, సో కరెంట్ అనేది ఈక్వల్ గా స్ప్లిట్ అవుద్ది. సో I1/2 flowing through this 20 ohm and remaining I1/2 flowing through this 5 and 50 because this is also 20. Right? Now tell me what is the value of the current flowing through 15 ohm resistance in terms of I1? I1/2. Good. It is the I1/2. So current flowing through this 15 ohm resistance equal to I1/2 అయితే what is the value of V2?
15 into I1/2.
Right, good. So 15 into I1/2 that is equal to V2. అంతే కదమ్మా, 15 into I1/2 that's equal to V2. సో దాన్ని మనం ఎలా రాసుకోవచ్చు, 15/2 into I1 కదా. సో 15/2 అంటే 7.5. సో 7.5 into I1 that's equal to V2. 7.5 into I1 that's equal to V2. Now నాకు Z21 కావాలంటే ఏం కావాలి,
V2 by I1.
I1 that's equal to 7.5, right? అంతే కదమ్మా. I will V2 that's equal to ఏమవుతుందమ్మా, that's equal to I1/2 into I1/2 into 15 కదా. ఇది ఓకేనమ్మా. సో దట్స్ ఈక్వల్ టు ఏమవుతుంది ఇక్కడ, I1/2 into 15 అంటే దాన్ని ఎలా రాసుకోవచ్చు, 7.5 into I1, right? So finally I can write V equal to 7.5 I1, and we know that Z21 equal to ఏంటమ్మా, V2 by I1. కనిపిస్తుందా మీకు? హలో,
Yes, sir. కనిపిస్తుంది సార్.
tell me what is Z21 that's equal to V2 by I1 that's equal to, నేను ఇక్కడ బాక్స్ లో రాశాను కదా, బాక్స్ లో రాసింది కనిపిస్తుంది అనుకుంటున్నాను. సో Z21 ఏమవుతుందమ్మా, V2 by I1 that's equal to 7.5 ohms. Equal to 7.5 ohms. ఇది ఓకేనమ్మా. సో సిమిలర్లీ ట్రై టు క్యాలిక్యులేట్ Z12. Is a Z21 equal to V1/2 that equals 10.5 ampere ohms, and similarly calculate Z1. సో ఈ ప్రాబ్లం మీరు ఓన్గా ఇంటి దగ్గర ఖాళీ టైంలో ఒకసారి ప్రాక్టీస్ చేసి రేపు క్లాస్కి వచ్చినప్పుడు మీకు ఏదైనా డౌట్ ఉంటే నేను ఒక 5 to 10 minutes ఈ ప్రాబ్లం మీద డిస్కస్ చేద్దాం. సో మీకు ఏదైనా డౌట్ ఉంటే నాకు అప్పుడు చెప్పండి, అగైన్ వీ విల్ డిస్కస్. ఈ ప్రాబ్లం మీకు సొల్యూషన్ కావాలంటే మొన్న 2 days బ్యాక్ మీకు ఒక 2-port నెట్వర్క్ పారామీటర్స్ అని ఒక PDF ఫైల్ షేర్ చేశాను కదమ్మా గ్రూప్ లో.
Yes, sir.
సొల్యూషన్ ఉంటుంది, చేసుకోండి ఏమైనా డౌట్ ఉంటే.
Yeah, okay, sir.
You have any problem, we will discuss in the tomorrow session. Okay, Nama?
Okay, sir.
So tomorrow also we will meet at 4:50. Okay, we will continue up to 5:30. The Zoom is extended, then we will go beyond that one. Sarenama?
Okay, sir.
Okay, thank you.
Okay, sir.
And ఎవరైనా సిఆర్ గాని ఎవరైనా ఇప్పుడు మనం డిస్కస్ చేయండి, ఎవరైనా షేర్ చేసి ఉంటే నాకు ఒకసారి నాకు వాట్సాప్ చేయండి, పర్సనల్ వాట్సాప్ నంబర్.
Yeah, okay, sir.
ఓకేనమ్మా.
Okay, sir.
Okay, sir.
థ్యాంక్స్ అమ్మా.
Yeah, okay, sir.
4:50 కి.
Thank you, sir.
Yeah, okay, sir. Thank you so much, sir.
ఓకే.
Thank you, sir.
Bye.
Thank you, sir.
ఓకే అమ్మా. Mostly.